Hello guys, welcome to the 25th video of our Python playlist, and in this video we will discuss that why we need object-oriented programming. So let's say that you are developing a car rental system. So if a car is rented, at the same time it cannot be rented again to anyone else, right? It can be only rented if a person, if that car is not rented at the moment. If it is not rented at the moment, then we can rent it out to any person that wants the car. So let's say that building a car rental system. So we have two cars right now, car one and car two. So car one make is Toyota and car one model is Corolla. Car one color is gray. Car one year is 2024. Car one price is £50 and car one rented is equal to false. This means that this particular car is not rented at the moment. Other than that, we have another car now, and that is car 2. Okay, so car 2 again, and this time it is, let's say, Honda uh, City Gray 2021, and the price is, let's say, £40. Right? We are renting these cars actually. So this is the simple basic information of the cars. It looks fine so far because we only have two cars right now. So if a person writes or if a person inputs Toyota to be rented, so if the car one uh, is not rented, so we can see that like the car one make is Toyota. All right. Now so far this code looks fine, but what if we have 50 cars, right? So for 50 cars, we will be having car 2 make, car 3 make, car 4 make, car 5, etc. So this will be consuming like almost 5 times 50. So 250 lines for just writing the data. And we cannot support that, right? So basically, we will be copying and pasting this structure again and again. Now, what is another problem? In the same particular case, let's say we define a function. If you are new to our YouTube channel, so you can see the functions video in our previous videos. So don't forget to subscribe to our YouTube channel. So let's say we define a function that is rent car, and it basically takes car name and car make as an input. Okay. Now what we will do, we will basically, or we can say car model over here, car model. Now the thing is that if, for if conditions, you can also watch our previous videos. We have in detail discussed how we can use the if conditions. So if car underscore model is equal to car one underscore model, right? And car underscore make is equal to car one underscore make, then what we can do, there we have to see another thing. What is the thing? That if car one underscore rented equal equal true, then we will say that print sorry, this car is already rented. Otherwise, we can say what we can do is that let me take uh, the global variable over here. because we are going to change this variable, that car1 underscore rented, right? So car1 underscore rented is taken as a global variable, right? So now what will happen, that car1 underscore rented will be converted to true. This means that we have entered a car, model and car make. If that car model and car make exist, what we will do in where it exists in the first car's data. So what we can do, we can see that if that car is already rented or not. If it is rented, then we will say, sorry, this car is already rented. Otherwise, we will say that we will basically rent that car, right? So we can print over here. Now you can take the car with you, right? Then what we'll do, we'll write the same condition for the other car. So for that we'll write elif, and here we will copy all these details, but just replace car 1 with car 2. So that same scenario will happen for the other car. Car 2, car 2, same here, here, and here, right? Now the thing is that if we have, like previously when we discussed that if we have 50 car, the record of 50 cars, it will take 250 lines. And if we see about this rent car function, right? So it will take, like, same goes with the conditions. We will have to write many conditions over here also for all the 50 cars, right? Other than that, we are using the same function body, but overall, the name will be changed to return car. So in case of car return, what will happen? We will just change the conditions. Is so this means that if a car rented is false, then we will say, sorry, this car is not rented at the moment, right? Other than that, we can say that we will convert the true to false. Thank you for using our services, right? Other than that, for the second car, we will also change this. It will turn to false. We change this if conditions, the print statement also, and same goes over here, right? And here we will change rented to false. So if we see this function, right? So it also, occupies many lines. So overall, if we just take these two functions only, and with that 50 car details, so it will take almost 1000 to 2000 lines, and some of the conditions will, like, make our function not to work perfectly. Why? There can be many cars that may have the same car model and same car make, right? But their year can be different. So overall, in this particular scenario, there are many chances that, for example, I am expecting to take 2025 model car and I was given 2021 model car, right? So in that case also, that if we get all the inputs from the user, that what car, what model, what color, what make, right? So overall, there will be many if conditions being written in these functions. This is a summarized code so far, because we are only taking just two cars, right? All right. Now we can see that this code is so complex, right? So let we move to our a simpler logic. I told you guys that the dictionaries are similar to objects, but we still need object-oriented programming to perform some specific task about an object, right? So In dictionaries, what will happen that let we take cars as a list, and inside that list we have two dictionaries, one denoting one car information and the other denoting other cars information. So let's write over here make, that is Toyota, comma, model, that is Corolla, color, that is gray, right? Year, that is 2025, and price, that is $50 again, and the rent, if it is rented, that turns out to be false. Okay, let me use this again over here, and we just change it to Camry and 2021. Let's take it to Honda also, and Honda Civic, and the price should be, let's say, $40, £40, right? So in this scenario we will have a simpler logic for, let me write a function def dict rent car. So here we just take the car make and car model, and here we will write that for car in cars, what we will do, we will just see that if the name of the car, the make of the car basically is equal to car underscore make, and the model of the car is equal to car underscore model double equal to car underscore model. So in that case, we will just change the car rented to true, right? So this is the working of our scenario now. Like we use dictionaries, it somehow reduce the code length, but still it is not as perfect as object-oriented programming. Now let me move to the other function. So that is dict return car. So in that scenario, we will just uh, change the condition. Let me write over here also that the car rented condition must also be false. Must also be false. So this is how, and over here, and this. Now it will work fine. Now the thing is that overall we are just, from this large line of code, huge line of code, we reduced our code, but still it is not the best code, right? This overall works better, but it is not ideal, right? Every function must check names manually, right? You still have, no structure that is tying the data and the behavior. So in that case, like even if in this scenario we have 200 cards, we have to use the loops and we have to use the same structure. So for that scenario, we need to organize the data. We need to organize a car. We need to organize the details so we can reuse that code again and again, right? For the reusability, for better performance, we use the object-oriented programming. So that's all for today's video. In the next upcoming video, we will discuss that how we can deal the same scenario with OO. So see you guys until the next video. Take care. Goodbye.